thing, how the sound is produced. It's known as amplitude. And amplitude is the maximum height of the wave. Nocturnal animals mean which are active during night. Like nowadays, many children, they are active during night. So they are becoming nocturnal nowadays. It's a very simple and easy chapter. Okay. Sound is a very simple and easy chapter. And it is very scoring also for ICSE. So in sound, the basic things we'll like to understand is the first thing, how the sound is produced. How the sound is produced. So sound is produced due to vibrations. Due to what? Vibrations, yes. Now, when we say vibration, now vibration will not happen automatically, no. Vibration will happen due to energy. What happens? Molecules, when they get energy, after getting the energy, the molecules get excited. And when the molecules get excited, then they collide with each other. And when the molecules collide with each other, then due to collision, the vibration starts. What happens? The vibration starts. And when the vibration starts, then the vibration will make a wave, and then that wave will be transferred from one medium to another medium. Understood? Then that wave from one medium to another medium, and it will be transferred then to a person. When he will have the sensation of hearing, then he will be able to listen or hear that particular sound. Understood? So sound needs vibrations, then the sound needs medium also. What does it needs? Medium also. Okay, sound is produced due to vibrations, and vibrations, I told you, vibration happens only when the molecules, when they get excited, when they get energy, then they collide, and after the collision, vibration happens, and that vibration needs a medium to travel. Understood? Now, I would like to just give you a little basic concept of sound range. 20 Hertz to 20,000 Hertz. 20,000 Hertz is also known as 20 kilohertz. 1000 means kilo. So sound range between 20 Hertz to 20 kilohertz. This is known as sonic waves. What? Sonic means audible. Means what? Audible. Now sound below 20 Hertz. Sound below 20 Hertz are known as infrasonic. Infrasonic waves. And sound above 20 Hertz. Sound above 20,000 Hertz or 20 kilohertz are known as ultrasonic waves. Okay, so these things are there in class 9 only. This is just a revision for you. 20 Hertz to 20,000 Hertz or 20 kilohertz is sonic or audible, which humans can hear. Below 20 Hertz are your infrasonic waves, which dogs, cats, they can hear this sound. And above 20 Hertz or 20 kilohertz sound is known as ultrasonic sound waves. Okay, these sounds can be bats. You know bats? Bats can produce these 20,000 Hertz sound. So bats, they produce that. They are ultrasonic waves. Alright. Now also one more thing. When we talk about sound, we have seen this expression V is equals to F into lambda. So V is, what is V? Speed, velocity of sound. V is velocity of sound. F is frequency of sound. And this lambda represents wavelength of sounds. Wavelength of sound. Alright. So V is velocity of sound, frequency of sound, and wavelength of sound. So when we talk about velocity of sound is the product of the wavelength and the frequency. Velocity of sound is what? The product of frequency and wavelength. Understood? So this expression is required when we solve the numerical problems related to frequency and wavelength of the sound waves. Alright. Now, for frequency, I would like to say you one more thing. Frequency is also expressed as 1 by t. T is your time period. T is your what? Time period. Okay. So, frequency is also called as inversely proportional to time period. Frequency is inversely proportional to time period. Okay. And frequency unit is hertz or second inverse. What? Or second inverse. Understood these things? These are basic things in sound. Frequency unit is hertz or second inverse. Alright. Now, next thing which I would like to say you is regarding the wavelength of sound. Okay. Now, wavelength means the distance between the waves. The distance between the waves. That is your wavelength. Okay. So, like suppose this is a sound wave here. One complete sound wave in here. So, this distance is known as amplitude. What distance is known as? Amplitude. Amplitude is the maximum height of the wave. Amplitude is the maximum height of the wave. So, this amplitude. And these two positions here, position A and position B here, the distance between these two waves, is only known as lambda, wavelength. So, wavelength is the distance between the two waves of the sound. Understood? Now, like I told you, the medium, sound needs a medium to travel. Because when we talk about the vibrations, then sound cannot travel if there is no medium. Now, medium can be anything. Medium can be solid, medium can be liquid. Okay. So, medium, when I talk about medium, then the question comes, does sound travel in vacuum? What do you think? Does sound travel in vacuum? Sound cannot travel in vacuum. Why? Because in vacuum, vibrations will happen. Because this experiment is there in class 9. You have done, in class 9, Bell-jar experiment. What experiment? Bell-jar experiment. So, in Bell-jar experiment, what we have seen? In Bell-jar experiment, we have seen that after the vacuum is present inside that jar, when the vacuum is on, when the vacuum is there, then in the presence of vacuum, the gong hit the bell. The gong continuously it hit. But the sound is not being heard by the people. Which means that vibration is happening. Vibration is occurring. But sound is not traveling because there is vacuum. And when air is present inside the jar, then what happens? Then yes, we can hear the sound. Because air acts like a medium. So, sound can travel in solid, in liquid, and in gases as well. But sound cannot travel in vacuum. Understood? Now, medium can be anything like I told you, solid, liquid, and gases. Sound travels very, very fast in solid. Sound travels very, very fast in solid. Then little bit slow in liquid. Then sound travels least in gas. So, speed of sound is more in which medium? In the solid medium, yes. So, in the solid medium, the speed of sound is more. Then in liquid, then the speed of sound is very, very least in gas medium. Understood? Now, when I say medium, there are some, medium, the requirements of the medium. Like, we need to know how the medium should be. So, the medium must be elastic in nature. When I say medium, the medium must be elastic in nature. Now, when I say elastic means the medium must be able to, like there are different particles. Like, so when I say in air there are different particles. Present, which we cannot see with our naked eyes. In air, there are different particles here. But with our naked eyes, we cannot see them. Right? So these particles, what happens when the sound is produced, then these particles, they absorb the sound. They absorb the sound. Then what will happen? This particle, it has the ability to pass that vibration to the another particle. Then again, this particle will take the sound, or it absorbs the sound from the first particle. So this particle will transfer the sound to the other particle. Then other particle, like this, the sound keeps on traveling from one particle to another particle. And when the particles are passing the sound waves, then this particle has the ability to pass the sound wave and again come back to its own place. This is called elasticity. What is this called? Elasticity. So the particles must be elastic in nature. Understood the ability? Okay, so particles must be elastic in nature. Now, what is the difference between light and sound? Now see, we know that till now, light is the fastest medium in this universe. Light speed is 3 into 10 to the power of 8 meter per second in air or in vacuum. So light is the fastest object, we can say. Now, difference between light and sound is light is the most fastest, but sound speed is not fast than light. Light is 3 into 10 to the power of 8 meter per second, whereas sound is 330 meter per second in air. Between 330 to 340 we can say. Okay, so 330 to 340 meter per second is only the speed of sound in air. So you can see light is the fastest object, whereas sound is not the fastest one. Now, sound needs medium, but light does not need medium to travel. This is another difference between light and sound. Understood the point? The waves of light are transverse in nature and the waves of sound is longitudinal in nature. Now, when I say elastic waves, now see what does this mean. Now see, the waves are of different kinds. One is called elastic waves. Okay, first I'll drop this much, okay? Then I'll come to these waves. Mechanical waves I'll talk about, okay? First, mechanical waves. The mechanical waves are of two types. One is longitudinal transverse wave, okay? When there are compressions and rarefactions, this is called compression and this rarefaction, okay? So when there is compressions and rarefactions in the medium, then this wave is called as longitudinal wave, all right? Whereas when there is crests and trough, when there is what? Crest and trough. Now see, crest trough is also quite similar only. Crest trough is this crest, this trough, crest trough. So when there is crest and trough, then that is called transverse wave. What wave? Transverse wave. Okay. Now, next thing is we'll understand about reflection of sound waves. What will understand? Reflection of sound waves. Yes. Now see. Now you know that light gets reflected. Yes or no? When light travels, then when light travels, what happens? When there is obstacle, when there is surface, then the light gets reflected. It bounces back. In the same way, sound also is produced when it is traveling from one medium to another medium. Okay, then there are some obstructions, there are some, obstacles where the sound gets hit and then it gets reflected back. So that is called reflection of sound. And due to reflection of sound, what is produced? Echo is produced. So echo is result of what? Echo is result of reflection of sound. Echo is result of reflection of sound. For example, if I am standing here, if there is some wall, if there is some cliff, and if I am speaking, then my sound waves gets hit by the cliff, it gets hit by the obstacle, by the wall, and then it gets reflected back. So echo is the reflection of the sound. Understood the point? Now, for producing echo, there is a condition. There is what? Condition. Now, what is the condition of the echo? Okay. Now, the condition for echo is number one, distance. Distance of the source of the sound and the obstacle. That minimum distance should be 17 meter. What? 17 meter, yes. This is the first condition of the echo. Okay. So between the source of sound and the reflector of the sound or the obstacle, that minimum distance should be 17 meters. Okay. Now this is calculated by one calculation. I'll show you how. So do you know this formula? Speed is equals to distance by time. We'll use exactly this same formula, but here my speed will be velocity. What would be velocity? Okay. Now when I'm standing here, and when there is a reflector here, what is this reflector? Reflector of sound. It can be anything, wall, it can be cliff, or it can be anything, any obstacle. Now, when I'm standing here, then if I produce sound, then my distance, the sound will travel this much distance, let it be d. Yes or no? Now, sound is traveling one complete d, that is particular d, let's say, let it be x or d. This distance it is traveling till here, and after that, this distance, after traveling, it will hit here, and after hitting here, the sound will travel backwards, which means this is another d. Yes or no? So to hear an echo, your distance becomes 2d. Your distance becomes what? 2d. Understood? And time is, let's say, t. Time is, let's say, t. Time. And in air, my sound is traveling where? In air. So in air, the speed of sound is how much I told you? 3? How much I told you? 340? 330 to 340. Okay. So in air. So speed of sound in air is 340 meter per second. 340 meter per second. So I'll take the value here. 340 meter per second is equals to 2 into d by t. 2d by t. Understood? And one more thing I would like to say you is, like distance I told you, 17 meter, it should be minimum distance. And there is one more thing, the time of producing the sound and hearing an echo, the minimum time gap should be 0.1 seconds. Understood? This is the minimum. What I'm talking about minimum, yes. Like minimum distance, it should be 17 meter. That we are proving right now, how 17 meter will come. Okay, this 17 meter, how it is coming, we are proving here. In the same way, how 0.1 second, that is the minimum time. 0.1 second is the minimum time duration to hear an echo. So, instead of t here, I will substitute my time value as 0.1. Then 340 into 0.1 will go up according to the maths. 2 will come down is equals to d. Now we'll solve this. Okay, 2 ones are 2, 2 17s are 34, right? 2 ones are 2, then 3 will be 14, so 1 7. Now there is decimal here, no? Decimal here, 0.1, and there is multiplication sign. So when there is multiplication sign, then what will happen is, or you can do one thing, you can remove the decimal here, you'll put here 10, 0, 0 cancel. So therefore d is equals to 17 meters. Understood the point? Very easy. So now you understood why distance is coming 17 meter. So this is the proving of hearing an echo. The minimum distance should be 17 meter. And second conditions says that the minimum time to hear an echo, it should be 0.1 second. Yes. So these are the two basic conditions for echo. In ICSE, sometimes the question comes, what are the conditions to hear an echo? So the two conditions to hear an echo is or are, number one, the minimum distance to hear an echo. The minimum distance to hear an echo. Distance of what? Distance of source of the sound and the reflector. The minimum distance should be 17 meter and the minimum time should be 0.1 second. These are the basic conditions to hear an echo. Now there is one more term called reverberation. What? Reverberations. Now sometimes we go into a big, museum, into a big hall, and then sometimes we speak something, then there will be multiple sounds. Like suppose if I'm shouting, let's say I'm saying hello, then I'll say hello, hello, hello. 2, 3 echoes, multiple echo you can say. So that is your reverberation. That is not, it's a form of echo only. Reverberation is also a form of echo, but that is not exactly echo. Because there are multiple sounds, one after the other you are able to hear. So that is called reverberation. Okay. Now reverberation is an effect of the echo where there is repeated reflections of sound. Where there is what? Repeated reflections of sound. Because in museum, in the big halls, okay, there's distance is very huge. The hall is very huge. So the sound has ample space to get reflected. So multiple reflection can occur over there. So where multiple reflection can occur, there multiple echoes can also be heard because of multiple that reflectors are there. Due to that, what happens? Multiple reflection of sound can happen, and due to that, reverberation is produced. Echo can be used in many ways. Like the first thing is bats. You know bats? Yes. Bats are called as nocturnal animal. What animal? Yes. Do you know what does nocturnal mean? Nocturnal animals mean which are active during night. Like nowadays, many children, they are active during night. So they are becoming nocturnal nowadays. So nocturnal animals, nocturnal means when they are active during night. So during night, bats get active. Okay. And they produce a high frequency of 20 kilohertz, ultrasonic frequency, ultrasound they produce. So when they produce ultrasound, what happens? That frequency, that waves, it travels. And if there is obstacle, then sound gets reflected back. And when the sound gets reflected back, the bats can hear the echo of their own sound. Then they will be alert that there is an obstacle over there. They cannot see during the night times. So they are nocturnal animals. Okay. So now when they will hear the echo, then they will change their path. And if they produce sound, and if they are not getting the echo back, then they will think that the path is clear, then they will travel in their own, that same path. They will not change the path. So they will change the path only when, after producing the sound, they hear the echo. When they hear the echo, then they will change their path. So the first one, use of echo is bats, they use the echo. Then we also know this USG, ultrasonography. Nowadays in medical science, ultrasonography has become very common, no? For any problem, doctor recommend go for ultrasound. Yes or no? So in ultrasound, what they use? They use the principle of echo only. Okay, they use the principle of echo. Okay, so ultrasonography is done due to echo. Then this sonar, sound navigation and ranging. Sound navigation and ranging. This is applicable for ships. For what? Ships. When the ships are traveling in the sea. Now, under the sea water, they don't know whether there is iceberg, whether there is big rock, they don't know. So what they do, they will send ultrasonic waves, and when the echo comes back after hitting the, when the echo comes back, then there is an obstacle. So the sailor will be alert and he can change the direction of the ship. So sound navigation and ranging, it's a technology which is used by the principle of echo to identify any obstacle or not inside the sea. So these are uses of echo. So students, today we have learned about sound. So for ICSE sound part A today we have completed. Now in the next class we will discuss about part B. In part B also there are many interesting topics like natural vibrations, dam vibrations, force vibrations. So we'll understand about the differences between these vibrations in the next class. So see you all in the next lecture. Thank you.